Hi friends, so hope you are doing well. So today let's break down Kubernetes architecture in the most simple and understandable way. So let's get started. So what is Kubernetes? So Kubernetes is an open source container orchestration platform. It automates the deployment, scaling and management of containerized application. So we are in short form we are calling it as a K8s. Why? Because between K and 8 we have 8 letters in between, so we are calling it as K8s. So it was originally developed by Google and is now maintained by the Cloud Native Computing Foundation, which is CNCF. So now it is a bit confusing. Why do we use Kubernetes? Right? So imagine if we have dozens or hundreds of container mini package applications. Without Kubernetes, you have to manage them manually. Where to run, how to scale, how to restart if one fails. So Kubernetes does this automatically by keeping them automatically running for 24 by 7, nearly zero downtime, scales up and down based on demand, yields itself if something fails or crashes. Okay, so no wonder big apps nowadays like Spotify, Zomato, or Paytm and more run on Kubernetes today. So, and most all major cloud providers like AWS, Azure, and Google and OpenShift supports it. If you see here, we have a Kubernetes. In Kubernetes, these are the packages or components that is being used. So Argo CD is there, and uh, Docker is there, etcd is there, Grafana is there. So all these components makes this Kubernetes architecture and application a strong building. Okay, so let's get go on to the next one. So this is a Kubernetes architecture. Okay, so where we can see two major components. Okay, one is master node, another one is worker node. So let me explain this architecture. Okay, so we have a DevOps user who is trying to connect to the Kubernetes. So some actions via graphical user interface or else command line interface. So here the API server acts as a front end and communicates with all the components and makes sure work is done as instructed. Okay, so here we have etcd, which is acts as a memory brain for the master node component, and we have two control manager is there. One is cloud control manager and kube control manager, and scheduler. The scheduler is responsible for scheduling the pods in the correct worker node based on the CPU and memory metrics and other configuration. In worker node, we could see there are three major components. One is Kubelet, it acts for some communication between master node and worker node, and Kube-Proxy is used for networking, uh, which is responsible for the communication, and container runtime where the actual work runs. So I hope it is you can see this architecture. Let's go on to the next one. So here it shows the architecture where each and every traffic how it is flowing. So let's consider the external system, which is Kubelet, continuous integration, continuous delivery system, monitoring system. It's communicating via API server. So API server acts as a front end on this, and the cloud platform is let's consider it as an AWS. It's communicating it with cloud control manager, and it is reporting to API server. So this API server, what is this, stores all the information, the key value stores in etcd. So that's why we calling it as a memory brain. So this API server uses the components like kube control manager, which is responsible for all the configuration, and kube scheduler. So it ensures that pod has been placed on the correct node and all the functionalities of the pod. Okay, in the worker node we have kubelet, which is responsible for communicating, Kube-Proxy for networking, and container runtime for running the actual work, which is the pod where it is runs. So here we're gonna see this Kubernetes in the more understandable way. So think of Kubernetes as a hotel. Okay, so the hotel has master node, which is hotel management, worker node, hotel flows with guest room. So here I have just differentiated in a table uh, like Kubernetes master node components, hotel Kubernetes master node components. So API server means hotel reception. etcd means hotel blueprint and booking details. Scheduler means room allocation manager. Control manager, which is hotel operation manager. Okay, so let's meet the hotel staff. So API server is equal to hotel reception. Okay, so this is the API hotel reception. So technically, it is the front end of Kubernetes validating and processing all API requests. So this is the API architectures. Okay, just like a hotel reception, all guests in our terms SDK libraries, monitoring system, third-party apps, Kubelet will come to request check-in, check-out, or room service. The receptional, which is API server, verifies ID authentication, checks guest list authorization, unlocks everything in the etcd, which is known as registry in hotel terms. Our terms is etcd. Okay, so this is how the API server works. Let's go on to the next component, which is etcd. So etcd is a combination of hotel blueprint and booking details. So technically etcd is a key or distributed key value store that holds a source of truth for the entire Kubernetes cluster state. So how it works? What is this functionality? Okay, so this is architecture diagram of etcd. So if it records every guest booking, which is pod definition, floor plan, which is node information, and service rule means what are the instruction which we have mentioned while creating the cluster configuration. So etcd acts as a brain database of Kubernetes, stores everything: pod, servicer, config mag, secrets, and etc. So if you check here, key spaces like pod live under registry prod, config maps under registry configuration. Okay, and secrets under secret registry secrets. So if etcd is lost, Kubernetes will no longer of which workload pods are running on which machine nodes or how they are configured. It's like erasing the hotel master registry. The guest pod might still be in their room nodes for now, but the management has no idea who they are, where they are, or what services they should be receiving. So that's the main key factor of etcd. So etcd should be needed for the functionality of the Kubernetes, because every detail is stored over there, so we have to get the details from there and make sure functionality is running properly. So next we're gonna see the next component. Here we're gonna consider scheduler as a room allocation manager. Okay, so when a new guest, which is new pod, okay, arrives to the API server, the room allocation manager checks all the floor, which is node, to find the most suitable for a place for them. They consider factors like available space like CPU and memory utilization, special requirements, trains, tolerance, affinity rules, and this comes into play as a load balancer, distributing pods evenly across the worker node. Okay, so one of the if one of the best is found, they assign the guest to the room which is binding the pod to a specific pod. Okay, so this is architecture where it shows how the scheduler is working and how the pods are getting placed on the container runtime. Hope if you see this architecture diagram, it is giving a wide view and understand it. So in Kubernetes term, the scheduler decides which pod should run on which node based on resource availability, scheduling policy, and constraint ensuring efficient and balanced workload distribution across the cluster. This is the main thing that scheduler will do. So our application will be running all the time. Okay, let's go to the next component, which is control manager. We often consider it as a brain, okay, because it controls everything in the Kubernetes. Think of control manager as a hotel operation manager. So I have just placed some robots. So let's think they walk around the hotel, the cluster node all day, holding the blueprint from the registry, which is etcd in our terms. Their job is to check if the current state matches the desired state. Basically, was set up before is still running as accepted now. Okay, so let me explain. So if a room is booked and it is empty, which pod is missing on a node, they request to set up a pod on the node. A new floor in the building has been created, which is our worker node. They inform the scheduler, room allocation manager, to replace the pod in the new node. Okay, so if a guest requests more rooms, which means more API requests or high workload, they scale up to meet up the increased demand, which is scaling up the pods. Okay, so this is the main operation this control manager will do, and they have several other components that is in place in control manager, as replica sets, endpoint controller, and other things are in there. But we're gonna see it in the overview, not in a detailed way. So this is the architecture diagram of that shows how kube controller and cloud control manager works. If you see, you could see how it is controlling and then scheduling the pod and maintaining each and every components and informing to the API server to perform the correct action on the worker node. And this cloud control manager, it's communicating with the cloud infrastructure and maintaining the correct infrastructure as instructed. Okay, all the resources will be up and running all the time. So this controller controls everything. So now we're gonna see the worker node components in hotel Kubernetes. Okay, so each worker node is known as hotel floor. Okay, so in this I have created a table which is Kubernetes worker node component, hotel Kubernetes worker node component. Here Kubelet stands for flow supervisor, Kube-Proxy means for hotel telephone operator, container runtime, room setup crew, pod, which is guest room where the actual work runs. So here we're gonna see the first component in worker node, which is Kubelet. Here we're gonna consider it as a flow supervisor. Okay, so what this flow supervisor do? Okay, this on each flow, which is worker node of the hotel, there is a flow supervisor. When the reception API server assigns the room, the supervisor makes sure the room is prepared exactly as requested. If anything breaks, they inform the hotel reception, which is API server, and arrange repairs. And Kubelet, in technically, it is an agent runs on each and every worker node. It gets pod specification from the API server and tells the container runtime to run them. It keeps checking the health of containers and reports their status back to the control manager and makes sure that that the work has been run as instructed by the API server. Okay, so now we're gonna see the next component, but this is the architecture diagram of the kubelet, how it is communicating and how it is instructing all the components in worker node to make sure the work is done. So next one is our container runtime. So container runtime, in our terms, we're gonna see it as a room setup crew. Okay. So on each floor supervisor gives the order. The crew moves into the room. They bring in the furniture, install applications, and make the room ready for the guest, which is our pod. Okay. Uh, this is the architecture of a pod which is will be running. Uh, so without them, which is container runtime, the guest, which is pod, would walk into an empty room. If a room is not ready, okay, if a guest is coming onto the room, it will be an empty room, no furnitures, no appliances, no TV, and etc. So this container runtime makes sure that all the packages and libraries is which will be there in place to run a pod. Okay. So the kubelet ensures the container, the guest on the node, which is floor, or running as specified in the pod definition. It continually monitors the health and reports status back to the API server, which is our reception in OTel terms. A container runtime in the engine that actually runs container. It pulls container images and create containers using OS features like C groups, namespaces. Kubernetes uses it via container runtime to start, stop, and manage containers on each node. Okay, so this is a definition or understandable way I have explained it, the container runtime. Now we're gonna see Kube-Proxy. So in our terms, a Kube-Proxy, we are considering it as a portal telephone operator. Okay, so every guest, which is pod, needs a way to call the room service, housekeeping, or other guest, which their friend might be staying on some other room, right? So instead of remembering each person's direct extension, the pod IP, which keeps changing, the operator, which is Kube-Proxy, connects the call to the right room. So in the background, if they remember the extension, they can easily connect to the correct room with the help of the Kube-Proxy. Kube-Proxy makes sure that when you call the hotel front desk service IP, your call always reaches the right room, which is pod. Even if room number changes, it assigns the call to the right person, right pod. Okay, so Kube-Proxy remembers all IPs and pod IPs and connects with external client, load balancer, and API server within the cluster and outside of the cluster as well. Okay, so that's why we are calling it as a networking part of Kubernetes. Okay, so this is the architecture diagram of Kube-Proxy, how it is remembering the pod IP addresses, cluster IP, and communicating with the external client and load balancer, and making sure that traffic is reaching to the correct port when the request comes in. Okay, so Kube-Proxy maintains a network rules on worker nodes. It forwards traffic from services to correct ports and provides load balancing across them. So this is the Kube-Proxy way I've explained it. Okay, next another component, which is main component, which is pod. Okay, pod, which is actually the work runs. We are gonna consider it as a guest room. Okay, so if it can host one guest, a single container, or a few related guests, multiple containers sharing the same facilities like network and storages. So let's consider on a room, one person is staying, which is a pod, and many guests are staying on the same room. So multiple pods can run on the same room. Okay, okay. When one guest leaves, which is a pod is deleted, the room is killed and made ready for the next pod to come in. So automatically, if one pod is failing, and another pod will be automatically created, that is created on the base of replica sets. Okay, so if you see that this is the all major components that we have covered for the Kubernetes. I hope it is very easy and understandable. So let's see the architecture of for how it is running and how the containers are getting created on the container runtime. So the pod is the smallest deployment unit in Kubernetes. If it wraps one or more containers that share the same network namespaces, IP port space, and can share storage volumes across them. When they die, they are replaced based on desired states, as I mentioned via replica set. In one liner, we can say pod, the basic execution unit in Kubernetes, grouping containers with shared resources. Okay. Um, Next, we got just covered all the components in master and worker node in Kubernetes architecture. The major components. I'm not covering all the sub components. I'm covering the major components. Now I'm gonna show the architecture diagram here. I hope if you see the architecture diagram Kubernetes, I hope you can say which components used for which purpose. Yeah, I hope so. We can say, right? So if you, after checking all the contents we have walked through, if you check this architecture, now I can understand which component is used for which purpose. Okay, so thank you so much for watching the video so far. So so next video we're gonna see the difference between a virtual machine and containers. Okay, thank you. Bye bye.